Randall Scott, Bryce. To remind you of our milestones, my milestone was to improve the neural network code. So I'm going to just show you the previous neural network code. I'm going to show you what I've done. What's the new neural network code that I've improved on, and I'll explain the differences. So originally, here's what the data set would look like. As you can see, the letters of the alphabet, and then after I ran my neural network that had 2 convolutional layers, 2 max pooling layers, a dropout, a flatten, and 2 final layers. And then after running the network, I tested it with a training accuracy of 98.7% and a validation accuracy of 98.9%, which is pretty good. And then I plotted that data on a chart, and as you see, the orange is the accuracy and the blue is the loss. And then down here it's just showing the prediction of the alphabet, of what the real alphabet was and the predicted alphabet letter was for 9 letters. And then after that, I'll go into the new neural code. The new neural network code is pretty similar. Only difference is I use Google Colab this time instead of Jupyter Notebook. The one difference in code is the data set primarily. So the data set that I used for the old neural network code was just all capital letters, which is a problem because we want our neural network to be able to recognize capital and lowercase letters and just distinguish it to a single letter. So in this case, to counteract that, I looked up and researched the EMNIST dataset. Specifically, I'm using the by letters dataset, which has capital and lowercase letters, as I'll show you. As you can see, for instance, if you can see my mouse is circling, there's a lowercase u, and right next to it is a capital U, and it has the same label. In this case, it's 20, but that's only until after I apply my dictionary I created for the letters. And then there's also a lowercase q and a capital G. Going to that dictionary, if you look here, I have the letters starting at 0, so A will be 0 for instance, and Z would be 25. And I have it labeled to the lowercase letter of that. So I decided to plot perform the same plot, but with my letters dictionary, just to make sure that it's appropriate in the same way. And it did. As you can see, the lowercase u is the capital U. They're the same letter U, as we can also see with our human eyes. So then I split the data into training and testing sets, and then I ran the same structure for the neural network with 2 convolutional layers, 2 max pooling layers, a flatten layer, a dropout layer, a dense layer, and a final softmax activation layer, with classifying between the 26 letters. And then, like I said, everything's pretty much similar except the data set's different. And then I ran it with 25 epochs and a 216 batch size. And after running it, I discovered I had a 97% training accuracy and a 92.9% validation accuracy, which is less than the previous neural network because it was at 98.9 and I think 98.2 or something like that. However, this is a better data set for what we want to do because we want to be able to look at lowercase letters and uppercase letters. And then after that, I plotted the data set again to where I can see what the test data did and the training data did. So as you can see with the accuracy, the training data went up to about 97% like it said, and then the test data started at about, I would say, 87%, and then it slowly increased and hung around that 93% area. And then with the model loss, started out with a high loss because just how it is when it runs the epochs, and then it gradually went down until the training data went less than 0.1%, so less than 10% loss, and then the test data started at about 0.4, and then it's hung around and it's lingering in between this 0.2 and 0.3%. 0.2, 20% and 30% loss, which means I'm gonna guess it's like 26 or 27%, somewhere around there. And I would say even though it's a lower accuracy, it's a better data set that's been tested on, which improves the network for the functionality that we're using.